The Big Bang did not bang. There was no explosion, no thunderous cosmic roar signaling the birth of everything. The universe didn't burst into existence, it stretched into being. In absolute silence, the most significant moment in cosmic history happened without a single witness, without a sound. This is our first misconception about the universe, that its beginning resembled our human understanding of creation. It did not. And this is merely the first of many illusions we must shatter if we are to comprehend what lies beyond the edge of everything. You've been told the universe is expanding, but expanding into what? If the universe contains all space, all matter, all time, then what exists beyond its boundaries? What canvas does our cosmic painting stretch across? This question has haunted humanity's greatest minds for centuries, and the answers defy our most fundamental intuitions about reality itself. Consider for a moment what we mean by edge. In your everyday experience, edges are definite. The shoreline where land meets sea, the horizon where sky meets earth. But cosmic edges are different. They're not places you can visit or boundaries you can touch. They're horizons of knowledge, limits of perception, and they're far stranger than you might imagine. Close your eyes. Imagine traveling in a straight line, never deviating, moving at impossible speeds across the cosmos. What would you eventually reach? Another galaxy? The dark emptiness between galaxy clusters? A vast cosmic void? And then what? Would you hit a wall? Fall off an edge? Loopy? Back to where you started? The answer will challenge everything you think you know about space itself. The truth is both simpler and more profound than our limited minds can easily grasp. We exist within a cosmic bubble of perception, a sphere of visibility approximately 46.5 billion light-years in radius. We call this the observable universe, not because it's all that exists, but because it's all we can see. Light from beyond this boundary simply hasn't had time to reach us since the universe began. But this isn't the edge we're seeking. This is merely the limit of our vision, not the limit of existence. What if I told you that the universe might have no edge at all? That space could curve back upon itself, creating a finite yet boundless cosmos? Imagine an ant walking on the surface of a sphere. It can travel forever without encountering a boundary, yet the surface it explores is finite. Our three-dimensional space might curve through a fourth spatial dimension in exactly this way. You could travel forever in what seems like a straight line, only to eventually return to your starting point, having traversed the entire universe, without ever finding its edge. Or perhaps the universe is truly infinite, extending without limit in all directions. If so, then beyond our observable bubble lies simply more universe. More galaxies, more stars, more planets, stretching to infinity. An endless ocean of cosmos with no shore in sight. Such vastness defies comprehension. Infinity is not just a very large number. It's an entirely different category of existence. But what if neither of these is true? What if the universe does have an edge? A genuine boundary beyond which— what? Nothing? But what is nothing? Not empty space. Space itself is something. True nothingness would be the absence of space, of time, of physical laws. Can your mind even conceive of such a state? Can anything exist beyond existence itself? The questions grow more challenging, more disorienting. If the universe is expanding, what is it expanding into? The answer is both beautiful and unsettling. It's not expanding into anything. Space itself is stretching, creating distance, where before there was less. Galaxies aren't moving through space. Space is growing between them. The fabric of reality is being woven in real time, an ever-expanding tapestry with no loom to contain it. If you could somehow position yourself beyond the universe, an impossible thought experiment, but indulge me, you wouldn't see a cosmic bubble floating in some larger void. There is no outside to the universe. The universe isn't just everything within space and time, it is space and time. Beyond the universe isn't a where or a when. It's a concept our spatial minds cannot truly grasp. Perhaps the most profound possibility is that our universe is just one of many, a single bubble in an infinite cosmic foam. Each universe with its own physical laws, its own dimensions, its own concept of time. Some may be similar to ours. Others might operate on principles we cannot begin to fathom. What separates these universes? Not space as we understand it, but something more fundamental. A higher dimensional membrane, a quantum fluctuation, a boundary in probability space. If you could rewind time, what would you see? A moment of creation, or something else entirely? Our best models suggest that if you traveled back to the beginning, you wouldn't witness a singular point of infinite density exploding outward. Instead, you'd see all of space compressed into a state of extreme heat and density. Every location that exists today, squeezed into a volume still technically infinite, yet unimaginably small. There was no before the Big Bang, because time itself began in that moment. Asking what came before is like asking what's north of the North Pole. The question itself becomes meaningless. The edge of the universe, then, isn't just a physical boundary. It's a conceptual one. It's where our understanding breaks down, where the tools of science meet their limits, where mathematics begins to stutter. It's where we're forced to confront the possibility that reality is not just stranger than we imagine, but stranger than we can imagine. And yet, despite these mind-bending possibilities, we continue to push outward, to expand our cosmic horizon. With each new telescope, each new particle accelerator, each new mathematical model, we extend our reach just a little further toward that elusive edge. We are cosmic explorers mapping the territories of existence itself. So what lies beyond the edge of the universe? Perhaps the question itself is flawed. Perhaps we need to reconsider what we mean by beyond, what we mean by edge, what we mean by universe. Perhaps the answer isn't a place or a thing, but a fundamental reconceptualization of reality itself. As we journey through this cosmic exploration together, prepare to have your most basic assumptions challenged. Prepare to look at existence through new eyes. Prepare to stand at the precipice of understanding and gaze into the unfathomable depths beyond. For in seeking the edge of the universe, we are really seeking the limits of our own minds. And the beginning of wisdom is the recognition of how little we truly know. When astronomers gaze into their telescopes, they're not just looking at distant stars and galaxies, they're looking back in time. Every photon that strikes their instruments has been traveling for thousands, millions, even billions of years across the void. The light from Andromeda Galaxy left its source 2.5 million years ago, when our ancestors were first learning to craft stone tools. The radiation from the cosmic microwave background, the afterglow of the Big Bang itself, has been journeying through space for 13.8 billion years before finally reaching our detectors. We exist within a bubble of visibility, surrounded by a cosmic horizon beyond which we cannot see. Not because nothing exists there, but because its light hasn't had time to reach us yet. This is our first fundamental truth. The observable universe is not the entire universe. It is merely the universe we can see. But how much larger might the true cosmos be? Twice as large? 1,000,000 times? Infinite? The mathematics of our best cosmological models suggests something truly staggering, that the universe beyond our cosmic horizon could be at least 10 to the 23 times larger than what we can observe. That's a 1 followed by 23 zeros. If the observable universe were the size of a grain of sand, the entire universe would be larger than the Earth itself. And that's just the lower limit. But size alone doesn't capture the true mystery of cosmic boundaries. Let's delve deeper into the fabric of reality itself, space-time. According to Einstein's general relativity, space and time are not separate entities, but a single unified fabric that bends and warps in the presence of mass and energy. This fabric isn't just a static stage upon which cosmic events unfold, it's a dynamic, breathing entity, stretching and contracting according to the distribution of matter and energy within it. Imagine space-time as an infinitely flexible membrane. The presence of massive objects like stars and black holes creates deep wells in this membrane, causing nearby objects to fall toward them, what we experience as gravity. But the membrane itself is also stretching, pulling galaxies away from each other in what we call cosmic expansion. This isn't movement through space. It's the creation of new space between objects that aren't bound together by gravity. The remarkable insight from modern cosmology is that this expansion appears to be accelerating. Something, a mysterious force we call dark energy, is causing space itself to stretch faster and faster as time goes on. If this continues, there will come a time when distant galaxies recede from us faster than their light can travel toward us. They'll fade from view one by one, until eventually observers in the far future will see only their own galaxy surrounded by endless darkness. The cosmic horizon will shrink rather than expand, and knowledge that was once accessible to us will become permanently lost to future civilizations. This leads us to a profound realization. The universe has no center. Every observer, regardless of their location, sees the same basic picture. Galaxies moving away in all directions, with those farthest away receding fastest. It's not that we're at the center of an explosion. It's that space itself is expanding everywhere, carrying galaxies along with it. Imagine dots drawn on the surface of a balloon. As you inflate it, each dot moves away from every other dot. But none is at the center of the expansion. The center, if it exists at all, isn't on the surface. It's in a dimension the dots cannot access. But if the universe has no center, can it have an edge? Our intuition falls short here because we're accustomed to thinking about objects embedded within space rather than space itself. There are three main possibilities for the universe's overall geometry, each with profound implications for what might lie beyond. First, the universe could be flat and infinite, extending without bound in all directions. In this scenario, beyond our observable bubble lies simply more universe, endless galaxies, stars, and planets stretching to infinity. Second, the universe could be positively curved, like the surface of a sphere. In this case, space would be finite but without boundary. You could travel forever without hitting an edge, eventually returning to your starting point. The third possibility is a negatively curved universe, shaped like a saddle or hyperbolic plane, which could be either finite or infinite depending on its topology. Current measurements suggest our universe is astonishingly close to perfectly flat, so close that any curvature, if it exists, must be on scales far larger than our observable horizon. This precision is itself a cosmic mystery, demanding explanation. Why should the universe be so perfectly balanced between the different possible geometries? The flatness problem, as cosmologists call it, is just one of several fine-tuning issues that haunt our understanding of cosmic origins. Another is the horizon problem, the puzzling uniformity of the cosmic microwave background radiation. Regions of space that could never have communicated with each other somehow ended up with precisely the same temperature, down to 1 part in 100,000. It's as if two people who had never met or spoken somehow showed up to a party wearing identical custom-made outfits. Cosmic inflation, a period of exponential expansion in the universe's first fraction of a second, offers a potential solution to these problems. In this theory, what would become our entire observable universe was once a microscopic patch of space, small enough for equilibrium to be established throughout. This patch then expanded faster than the speed of light, which is possible when it's space itself that's expanding, stretching quantum fluctuations into the seeds of galaxies and smoothing out any curvature to near-perfect flatness. But inflation raises as many questions as it answers. What caused inflation to begin? What made it stop? And, most intriguingly, did it happen just once, or does it occur repeatedly in different regions of a much larger cosmos? This brings us to perhaps the most mind-bending possibility of all. The multiverse. Our universe, with all its hundreds of billions of galaxies and trillions upon trillions of stars, might be just one bubble in an endless cosmic foam. In some versions of inflation theory, the process that created our universe continues eternally in other regions, spawning new universes with potentially different physical laws and constants. Some might collapse immediately. Others might expand forever. Some might be hostile to life. Others might harbor forms of consciousness we cannot imagine. If the multiverse exists, then the edge of our universe isn't an edge at all. It's a boundary between different phases of reality, like the surface tension between two bubbles. Beyond our cosmic horizon wouldn't just be more of the same. It would be realms where the very nature of existence follows different rules. But here we reach the limits of empirical science. These bubbles, if they exist, lie forever beyond our observable horizon. We cannot directly detect them or test their properties. They exist in the realm of mathematical possibility, tantalizingly suggested by our theories, but perhaps forever beyond confirmation. If the universe has no edge, then where does it begin? If time itself was born in the Big Bang, what came before? If reality extends beyond the boundaries of our observation, how can we ever know the true nature of existence? These contradictions aren't just philosophical puzzles. They're the frontiers of our understanding, where science meets the limits of human comprehension. As we stand at this frontier, gazing outward into the cosmos and inward into the mathematics, that describes it. We find ourselves confronting questions that transcend traditional boundaries. What lies beyond the edge of the universe might ultimately be beyond the edge of our thinking, requiring not just new observations or theories, but new ways of understanding reality itself. In the silent darkness between galaxies, where single atoms drift light-years apart, the nature of reality reveals itself in ways impossible to observe from our crowded corner of the cosmos. Here, in the vast emptiness, space-time itself becomes the main character in our cosmic drama. But to truly understand what might exist beyond the boundaries of our universe, we must first grasp how that boundary came to be, and why the very concept of beyond might be fundamentally misguided. The story begins not with a bang, but with a singularity, a point of infinite density and zero volume where the laws of physics as we understand them break down completely. Imagine reality compressed to a mathematical point, where space and time lose all meaning. This wasn't just extreme density, it was the absence of space itself. Not smallness as we understand it, but the non-existence of extension. Time wasn't running quickly. It simply wasn't flowing at all. The singularity wasn't in the universe. It was the entire universe, compressed beyond the limits of our mathematics to describe. From this impossible starting point emerged everything: matter, energy, space, and time themselves. But how? And into what? The conventional language of physics fails us here because we instinctively want to place this event within a larger context, to imagine it happening somewhere at some time. Yet there was no somewhere for it to happen in, no before to precede it. Imagine reality as a film reel, where time is not flowing but every moment already exists. Now imagine that film begins not with a blank frame, but with a frame so saturated with energy that the very notion of location becomes meaningless. The Big Bang wasn't an explosion that expanded into empty space, it was the beginning of space itself. Every point in today's universe, including the space you occupy right now, was present at the singularity. The distances between points simply stretched as the universe expanded, like dots drawn on a balloon being inflated. This distinction is crucial. The universe didn't expand into anything. It's not a finite bubble with an outside. Rather, if the universe is infinite now, as observations suggest it might be, then it was always infinite, even at the earliest moments after the Big Bang. The infinite was simply compressed into a state of extreme density, then stretched by cosmic expansion. If you could somehow stand outside the universe, an inherently contradictory proposition, you wouldn't see a sphere growing larger. You would see nothing our minds can visualize. But the singularity poses a conundrum. Infinities are mathematical red flags, suggesting a theory has reached its limits. Just as Newton's physics broke down at extreme speeds, necessitating Einstein's relativity, so too does Einstein's relativity break down at the singularity, hinting at a deeper theory yet to be fully formulated. Enter quantum mechanics, the science of the vanishingly small, which offers a potential resolution to the singularity problem. In the quantum realm, certainty gives way to probability. Locations become clouds of possibility. Even emptiness teems with activity as virtual particles pop in and out of existence. Applied to cosmology, quantum mechanics suggests the singularity may have been not a mathematical point, but a quantum foam, a seething landscape of probability where space and time emerge through quantum fluctuations. This quantum beginning could have profound implications for what lies beyond our universe. If quantum mechanics governed the universe's birth, then our cosmos might be just one quantum fluctuation in a broader reality, one bubble in an infinite quantum foam. This idea forms the foundation of several multiverse theories, each with its own vision of what might exist beyond our cosmic horizon. The first, and perhaps most conservative multiverse theory, stems directly from cosmic inflation, that brief period of exponential expansion in the universe's first fraction of a second. According to the theory of eternal inflation, the process that inflated our universe continues endlessly in other regions, spawning new universes in a never-ending cascade. These bubble universes expand into their own spaces, possibly with their own unique properties, different masses for elementary particles, different strengths of fundamental forces, perhaps even different dimensions of space and time. Imagine our universe as a single soap bubble in an infinite foam. The space between bubbles isn't space as we understand it. It's a state of continuing inflation, a realm of pure potential where new universes are constantly being born. We can never observe these other bubbles because they exist beyond our cosmic horizon, expanding away from us faster than light can travel. Their existence is suggested by our mathematics, but forever beyond direct observation. A second, more radical multiverse emerges from string theory and its extension, M-theory. These frameworks attempt to unify all fundamental forces by proposing that the basic constituents of reality are not point-like particles, but tiny, vibrating strings. The mathematics of string theory requires extra spatial dimensions beyond the 3 we experience, typically 6 or 7 additional dimensions curled up so tightly we never notice them. But string theory doesn't yield a single unique solution. Instead, it produces a vast landscape of possible universes, perhaps 10 out of 500 different configurations, each with its own physical laws. This number defies comprehension. It's a 1 followed by 500 zeros, vastly exceeding the number of atoms in the observable universe. In this view, our universe, with its particular physical constants, is just one solution in this enormous landscape. One valley in an almost infinite terrain of possibility. A third conception of the multiverse arises from quantum mechanics itself. In the many-worlds interpretation, every quantum event, every moment when multiple outcomes are possible, doesn't resolve to a single result, but instead splits reality into multiple branches, each containing one possible outcome. The universe continuously fractures into countless parallel versions, differing initially in tiny quantum details but potentially diverging into radically different histories over time. If true, this would mean that beyond our universe lies an infinite array of parallel universes, some nearly identical to ours where perhaps you chose a different career or made a different turn on your morning commute. Others radically different where fundamental constants vary, and the very laws of physics might take alternative forms. Yet another approach to the multiverse comes from the simulation hypothesis, which suggests our entire reality might be a sophisticated simulation created by an advanced civilization. If true, beyond our universe would be the computational substrate supporting our simulation, and potentially countless other simulated universes, each with its own physics and history. While speculative, this hypothesis follows logically from technological trends. If consciousness can exist in a simulated environment, and if civilizations tend to create such simulations as they advance, then, statistically speaking, simulated minds would likely vastly outnumber original ones. The implications are dizzying. Our universe might be a nested simulation within a simulation, layers of reality stacked like Russian dolls, each with its own concept of beyond. These various multiverse theories offer potential answers to one of cosmology's most persistent puzzles: the apparent fine-tuning of our universe for complexity and life. Our cosmos appears balanced on a knife edge of possibility. The cosmological constant, the energy density of empty space that drives the universe's accelerating expansion, is over 120 orders of magnitude smaller than quantum theory would naturally predict. If it were slightly larger, the universe would have expanded too quickly for galaxies to form. Slightly smaller, and the cosmos would have recollapsed before stars could evolve. Similar precision appears in dozens of other physical constants. The strong nuclear force must be within about 0.5% of its actual value, or stars couldn't form the heavy elements essential for life. The ratio of electrons to protons must be equal to within 1 part in 10^37, or electromagnetic forces would overwhelm gravity, preventing galaxy formation. In a single universe, this precision seems to demand explanation, perhaps even suggesting design. But in a vast multiverse where every possible combination of physical laws exists somewhere, our existence becomes a matter of cosmic selection bias. We necessarily find ourselves in one of the vanishingly rare universes compatible with our existence, because we couldn't evolve to make observations in the vast majority of universes where physical constants prohibit complexity. But here, we reach the limits of empirical science. These other universes, whether bubble universes from eternal inflation, alternate configurations in the string theory landscape, parallel branches from quantum splitting, or different simulations in a vast computational substrate, all lie beyond our observable horizon. We cannot directly detect them or measure their properties. We are like deep-sea creatures trying to comprehend the surface world, limited by the boundaries of our environmental bubble. Our theories might hint at what lies beyond, but direct confirmation remains elusive. Yet the mathematics is compelling, hinting at a reality far vaster and stranger than our observable bubble. This brings us to the boundaries of knowledge itself. If the true nature of reality includes realms fundamentally disconnected from our observable universe, can we ever claim to understand the cosmos in its entirety? Or are we doomed to construct elaborate mathematical models that can never be fully verified? Perhaps the most profound question is not what exists beyond our universe, but whether the concept of beyond remains meaningful at the largest scales. If space itself is a property of our universe, rather than something our universe exists within, then asking what's beyond the universe might be like asking what's north of the North Pole, a question whose very structure contains a fundamental misunderstanding. As we peer deeper into the abyss of cosmic mysteries, we encounter paradoxes that shake the very foundations of our understanding. These aren't merely puzzles awaiting solution. They are potential windows into a reality far more complex than our evolved intuitions can easily grasp. To approach the edge of the universe is to approach the edge of comprehensibility itself. Consider the horizon problem, the mysterious uniformity of the cosmic microwave background radiation. This faint afterglow of the Big Bang has the same temperature in all directions, varying by only about 1 part in 100,000. Yet when this radiation was emitted, roughly 380,000 years after the Big Bang, opposite points in our observable universe were separated by distances so vast that light, and therefore any form of information or causal influence, couldn't have traveled between them. It's as if two people who had never communicated somehow wrote identical 1,000-page novels down to the last comma. How could regions of space that had never spoken to each other reach precisely the same temperature? Cosmic inflation offers one solution, suggesting these regions were once in close contact before being rapidly stretched apart. But this pushes the mystery back further. What caused inflation to begin? And why did it start and stop exactly as needed to produce our uniform universe? Even more perplexing is the flatness problem. Observations indicate that the universe's geometry is remarkably close to perfectly flat, neither positively curved like a sphere nor negatively curved like a saddle. This flatness requires the universe's expansion rate and energy density to be balanced with extraordinary precision early in cosmic history. The slightest deviation would have caused the universe to either recollapse almost immediately or expand so rapidly that no structures could form. It's like balancing a pencil on its point, not for seconds, but for billions of years. Without a mechanism like inflation to force this flatness, the initial conditions of our universe would need to be fine-tuned to within 1 part in 10^62, a level of precision that defies coincidence. But if inflation explains this precision, we're left with the puzzle of why inflation itself occurred with exactly the right properties. These problems hint at a deeper issue. Our universe appears suspiciously hospitable to complexity and, ultimately, to observers like ourselves. The cosmological constant, Einstein's biggest blunder that turned out to be real, exemplifies this mystery perfectly. According to quantum field theory, empty space should seethe with energy, resulting in a vacuum energy density so enormous it would tear apart atoms. Yet, the measured value is minuscule, smaller than theoretical predictions by a factor of 10 to the 120. This discrepancy is the largest gap between theory and observation in all of science. It's as if you calculated that a feather should weigh as much as a galaxy, then discovered your bathroom scale confirmed the feather's actual lightness. Something fundamental is missing from our understanding. The anthropic principle offers one perspective. Perhaps this apparent fine-tuning simply reflects the fact that observers can only evolve in universes compatible with their existence. In a vast multiverse with varying physical constants, we necessarily find ourselves in one of the rare universes where the conditions allow for complexity and life, just as fish only evolve in the tiny fraction of the Earth covered by water. But this explanation comes with its own paradoxes. If the multiverse contains infinitely many observers, how do we calculate the probability of being any particular kind of observer? This measure problem has led to bizarre conclusions, including the Boltzmann brain paradox, the unsettling notion that an isolated, disembodied conscious entity forming from random quantum fluctuations might be more likely than an entire organized universe producing conscious beings through the slow process of evolution. It's like realizing it might be statistically more probable for a tornado sweeping through a junkyard to assemble a single functioning calculator than a complete Boeing 747. In an infinite multiverse, seemingly unlikely events happen infinitely often somewhere. How then do we make sense of probability at all? The mysteries deepen when we consider the nature of time itself. Our intuitive sense of time as a river flowing from past to future dissolves at the frontiers of physics. Einstein showed that time passes differently depending on velocity and gravitational potential. Near a black hole's event horizon, time slows to a crawl relative to distant observers. Pushed to the limits, and time itself seems to emerge from more fundamental principles rather than existing as a primitive aspect of reality. Some theoretical frameworks, like the Wheeler-DeWitt equation in quantum gravity, suggest that at the deepest level, time might not exist at all. The universe in its entirety might be a four-dimensional block where what we perceive as now is just one slice through a static, higher-dimensional structure. Our sense of time flowing would be an illusion born from our limited perspective, like how a character in a movie experiences their story unfolding, even though the entire film already exists on the reel. If time is emergent rather than fundamental, what does this mean for the beginning of the universe? The Big Bang might not be a starting point in time, but rather a boundary of the space-time manifold itself, like the tip of a cone, a point where the smooth fabric of reality simply ends. Or perhaps what we perceive as the Big Bang is merely a transition point, with reality extending before it in ways our current theories cannot describe. This brings us to perhaps the greatest cosmological paradox, the nature of existence itself. Why is there something rather than nothing? Every scientific explanation eventually hits a wall of axioms that must be accepted without further justification. Even if we discover the ultimate unified theory of physics, the elusive theory of everything, we'd still face the question, why these equations and not others? Why does mathematics describe reality at all? Quantum cosmology offers one approach to this ultimate question through the concept of a universe from nothing. In quantum mechanics, empty space is never truly empty, but constantly fluctuates with virtual particles popping in and out of existence. Some theorists propose that our entire universe might be an enormous quantum fluctuation, a bubble of existence, that emerged spontaneously from a pre-existing quantum vacuum. But this simply pushes the mystery one level deeper. What are the laws that govern this quantum vacuum? Where do they come from? Why does this substrate for reality exist at all? At some point, explanation gives way to brute fact, or perhaps circles back on itself in ways our linear thinking struggles to comprehend. Modern cosmology increasingly suggests that reality might be fundamentally mathematical, that at its core, the universe isn't made of stuff, but of relationships, patterns, and information. The physicist Max Tegmark has proposed that the universe doesn't just follow mathematical laws. It is mathematics, a particular solution in the vast space of possible mathematical structures. In this mathematical universe hypothesis, physical reality is isomorphic to mathematical structure. The question, what exists beyond our universe, transforms into what mathematical structures exist beyond those describing our observable reality. The answer would be all of them. Every logically consistent mathematical structure would have its own form of physical existence. But if reality is fundamentally mathematical, why do we experience consciousness, subjective awareness that seems irreducibly phenomenal rather than purely structural? This mind-body problem, ancient as philosophy itself, takes on cosmic proportions at the boundaries of physics. If consciousness is somehow fundamental to reality rather than emergent from complexity, could the universe itself possess something like awareness? Might what lies beyond our universe involve modes of consciousness we cannot comprehend? These questions verge on the metaphysical, yet they arise naturally from our scientific pursuit of ultimate reality. As the physicist Werner Heisenberg noted, the first gulp from the glass of natural sciences will turn you into an atheist, but at the bottom of the glass, God is waiting for you. He wasn't advocating for traditional religion, but acknowledging how the deepest scientific questions inevitably blend into philosophical ones. Modern debates about cosmology often recapitulate ancient philosophical divisions. Those who believe our observable universe is all that exists echo the materialists like Democritus, who held that only atoms and the void are real. Proponents of the multiverse resemble Leibniz with his infinite possible worlds. Those who see mathematics as the ultimate reality follow in the tradition of Pythagoras and Plato, who placed abstract forms above physical manifestations. Even our language betrays these ancient roots. We speak of the laws of physics as if they were commandments, imposed on nature rather than descriptions of observed patterns. We ask what happened before the Big Bang, unable to escape our time-bound thinking. We struggle to imagine nothing without picturing empty space, itself a something with dimension and potential. Perhaps the most profound paradox is that we can contemplate these questions at all. We are collections of atoms assembled by blind, evolutionary processes on an unremarkable planet. Yet we can conceive of multiple universes, higher dimensions, and the birth of time itself. Our minds, products of a reality they seek to understand, attempt to encompass the totality that encompasses them. In the end, the boundary of the universe isn't just a physical horizon, but a conceptual one. The edge where science meets philosophy, where mathematics merges with metaphysics, where explanation confronts mystery. What lies beyond this boundary might be forever beyond our complete comprehension, not because of practical limitations to our knowledge, but because of intrinsic limitations to what embodied minds, evolved in 3 dimensions of space and 1 of time, can possibly conceive. Yet we continue to push against these boundaries, extending our mathematics, refining our theories, building more powerful instruments. Each generation peers a little further into the cosmic abyss. And perhaps the greatest revelation isn't what we might find beyond the edge of everything, but how the search itself transforms us, from creatures bound by immediate survival needs to beings capable of contemplating reality itself. In this moment, as you listen to these words, photons that left distant stars when dinosaurs ruled the Earth, are just now striking your retina. The iron in your blood was forged in the heart of a supernova explosion billions of years ago. The hydrogen atoms in the water you drink were born in the first moments after the Big Bang. You are not just in the universe. You are of the universe, a temporary arrangement of stardust that has, against all cosmic odds, become aware of itself. What does it mean to be a conscious entity in a potentially infinite cosmos? To be a fleeting collection of atoms capable of contemplating eternity? The implications of what we've explored aren't merely academic. They pierce straight to the heart of what it means to exist at all. Consider the unsettling possibility that time is an illusion, that past, present, and future all exist simultaneously in an eternal block universe. If true, then everything you've ever done and will ever do might already be fixed in this four-dimensional structure. Your future death already exists, as does your birth, as does every moment of joy and sorrow between them. Free will becomes a persistent illusion, the story you tell yourself as you move through a predetermined path. What meaning can choice have if all possible outcomes are already written into the cosmic equation? Or contemplate the dizzying implications of quantum mechanics, where reality itself remains indeterminate until observed. What if, as some interpretations suggest, the universe splits into countless parallel versions with every quantum interaction? In this moment, as your brain processes these words, trillions of alternative views are diverging into separate realities, some where you stopped reading, others where you continued but understood differently, still others where the tiniest quantum fluctuation in your neural patterns led to a completely different train of thought. You might be just one version of yourself in an infinite ensemble, a single leaf on a cosmic tree with endless branches. The you reading these words is unique in the multiverse, a specific configuration of matter that will never be repeated exactly, yet echoed with variations across an infinity of parallel realities. How thin is the line between you and not you? Between existence and non-existence? More vertiginous still is the possibility that our entire universe might be a simulation, that the fundamental laws of physics are actually computational rules in a program run by beings in a higher reality. If true, then the edge of our universe might be nothing more than the boundaries of a simulation, beyond which lies a reality we cannot begin to comprehend. Your most private thoughts, your deepest feelings, your sense of self, all might be simulacra in a cosmic computer. Not quite real, yet experiencing the perfect illusion of reality. But perhaps the most profound existential question arises from the anthropic principle, the idea that our universe appears fine-tuned for life because only in such universes could observers evolve to notice this fact. In a vast multiverse with every possible configuration of physical laws, we necessarily find ourselves in one of the rare patches hospitable to complexity and consciousness. This shatters our cosmic significance from two directions simultaneously. On one hand, our existence required an extraordinarily improbable set of physical constants, suggesting we are either incredibly lucky or the product of some deeper principle we don't yet understand. On the other hand, if the multiverse contains infinite variations, then what seems unique and precious, life, consciousness, you, might be commonplace on the largest scales, repeated with endless variations across the cosmic landscape. What value does your individual consciousness have in an infinite multiverse? If every possible configuration of matter exists somewhere, are you truly unique? If versions of you exist across countless parallel universes, which one is really you? The very concept of identity dissolves in the face of cosmic infinity. Look up at the night sky. The darkness between the stars is not empty. It's filled with the unseeable, invisible dark matter that outweighs all visible matter 6 times over. Unseen dimensions curled up at every point in space. Perhaps parallel universes hovering just beyond our perception. The cosmos is not just stranger than we imagine. It's stranger than we can imagine. The boundaries of human comprehension may be far more constraining than the boundaries of the universe itself. Now, feel the Earth beneath you. This planet, this infinitesimal mote of dust suspended in a sunbeam, is all we have ever known. Our entire species has lived out its existence on this pale blue dot, never venturing more than a few hundred miles from its surface. Yet, with our minds, we've reached across billions of light years. We've reconstructed the birth of the universe. We've conceived of realities beyond our observable bubble. We are cosmically insignificant, yet cognitively vast. Specks of dust that somehow contain universes of thought. What if the universe is alive, and we are just its fleeting thoughts? What if consciousness isn't something that emerges from complexity, but a fundamental aspect of reality itself? Perhaps what lies beyond the edge of our universe is not just more space, more time, more matter, but more mind. Perhaps the cosmos itself is gradually awakening, and we are but early stirrings in a cosmic consciousness that will eventually encompass realities we cannot begin to fathom. Or perhaps we are truly alone, the only observers in our observable bubble, with no guarantee that anything like us exists in the vast beyond. Perhaps consciousness is so improbable, so fragile, that even in an infinite multiverse, awareness remains precious and rare. This would make our existence not meaningless, but profoundly significant, caretakers of the only known awareness in our cosmic domain, custodians of the universe's ability to know itself. Feel the weight of your existence, the statistical miracle of your birth in this particular time and place. In the entire history of the universe, spanning nearly 14 billion years across 93 billion light-years of observable space, you exist in this infinitesimal slice. If the universe's history were compressed to a single Earth year, all of human civilization would occupy only the last few seconds before midnight on December 31st. Your lifetime would be imperceptible, a fraction of the blink of an eye. Yet here you are, conscious, aware, contemplating reality itself. The void beyond our universe might be empty space, infinitely extending. It might be other bubble universes with different physical laws. It might be higher dimensions we cannot perceive. It might be the computational substrate of beings who created our reality. It might be something so alien to our understanding that we lack the cognitive architecture even to conceive of it. But whatever lies beyond the edge of everything, know this: the fact that you can contemplate these possibilities at all is perhaps the greatest mystery of the cosmos. You, a temporary configuration of particles governed by the same physical laws that rule distant galaxies, have somehow developed the capacity to question your own existence, to wonder about realities beyond your perception, to feel the sublime, terror and wonder of cosmic infinity. In the face of these existential abysses, we have two choices. We can retreat into comfortable illusions of cosmic importance, placing ourselves at the center of a universe that increasingly reveals our peripherality. Or we can embrace the vertiginous freedom that comes with cosmic insignificance, the recognition that in a universe without inherent meaning, we are free to create meaning on our own terms. Perhaps this is the ultimate paradox, in a possibly infinite multiverse where everything that can happen does happen. The choices you make still matter profoundly. not to the cosmos, which continues unaware of your existence, but to the only observer for whom your reality is directly accessible, yourself. As you contemplate what might lie beyond the edge of everything, remember that you stand at the edge of another profound boundary, the frontier between unconscious matter and conscious awareness. In a universe that may be infinite in extent but finite in comprehensibility, you occupy the razor's edge where the cosmos has developed the capacity to question itself. And that, perhaps, is the most awe-inspiring mystery of all. As we've journeyed to the edge of understanding, we've encountered singularities where physics breaks down, quantum realms where certainty dissolves into probability, and cosmic horizons beyond which we cannot see. We've contemplated multiverses that boggle the mind and paradoxes that challenge our most fundamental assumptions. But perhaps the most profound realization, the one that changes everything, has been hiding in plain sight all along. What if there is no edge to the universe because the universe is not what we think it is? Imagine for a moment the most distant galaxy we can observe, a faint smudge of light whose photons have traveled for over 13 billion years to reach our telescopes. Now imagine traveling to that galaxy and looking back toward Earth. You would see our Milky Way as it appeared 13 billion years ago, a young galaxy still forming its spiral arms, our sun and planets not yet born. But you would also see a different cosmic horizon with different galaxies at its edge. Now travel to one of those galaxies at the edge of that horizon. Again, you would see yet another horizon with different galaxies at its boundary. No matter how far you travel, the observable universe moves with you. A bubble of visibility 93 billion light-years in diameter, with you always at its center. There is no edge to find because the edge is defined by the observer. This leads us to a shocking possibility. What we call the universe might be better understood not as a thing, but as a relationship. The relationship between an observer and the maximum volume of space-time they can potentially observe. The universe isn't out there, it's defined by the very act of observation. Without observers, there would be no cosmic horizons, no boundaries, perhaps no meaningful concept of universe at all. Take this one step further. In quantum mechanics, observation doesn't just reveal reality, it plays a role in determining it. Particles exist in states of superposition until measured, whereupon the wave function collapses into definite values. Some interpretations of quantum mechanics suggest that reality itself is observer-dependent, that the moon might not be there in quite the same way when no one is looking at it. What if this principle extends to the cosmos itself? What if the universe, as we know it, with its particular physical constants, its 4 fundamental forces, its 3 spatial dimensions, and 1 temporal, exists in this specific configuration precisely because we are here to observe it? What if, in some profound sense, we are not just in the universe, we are co-creating it through the act of observation? This isn't to suggest a naive solipsism, where reality exists only in our minds. Rather, it points to a deeper relationship between consciousness and cosmos than we've previously recognized. In the words of the physicist John Wheeler, who pioneered this perspective, we are participators in bringing into being not only the near and here, but the far away and long ago. Picture the birth of the universe, not as something that happened 13.8 billion years ago, but as something that's happening continuously, in every moment, through the interaction between consciousness and reality. The Big Bang wasn't just then, it's now. It's every observation that collapses quantum possibilities into definite realities. It's happening as you watch these words, as photons strike your retina and trigger electrochemical cascades in your brain that somehow, mysteriously, result in conscious experience. This perspective transforms our cosmic insignificance into something profound. We are not passive specks in an indifferent universe. We are active participants in a reality that requires observers to manifest its potential. The universe without consciousness would be like an unplayed symphony, a collection of possibilities never realized. Now imagine the cosmic vista this suggests. Stars explode in supernova, scattering elements across space. Some of those elements eventually coalesce into planets. On some planets, complex chemistry gives rise to life. Some life evolves intelligence. Some intelligence achieves consciousness. And consciousness observes the universe, collapsing its quantum wave function, defining its boundaries, completing the cosmic circle. What lies beyond the edge of the universe? Perhaps the question itself contains a fundamental misunderstanding. There is no final edge to find because the edge moves with the observer. There is no absolute beyond because beyond is always relative to here. The universe isn't something separate from us. It's something we're intimately involved in bringing forth. But this raises a disturbing possibility. What if the universe is actually dying, and we are just complex patterns of information processing arising during its long, slow heat death? What if what we perceive as a 13.8 billion-year history is actually the universe's final moments, stretched to near infinity from our perspective within it? Like the view of someone falling into a black hole, watching the entire future of the external universe unfold as they approach the event horizon. Some cosmological models suggest that time itself is an emergent property, not a fundamental dimension, but a byproduct of entropy increase. What we experience as the flow of time might be the universe's gradual journey from order to disorder, from low entropy to high entropy. In this view, the Big Bang represents a state of extraordinarily low entropy, a cosmic egg of maximum potential, and everything since has been the playing out of that potential into increasingly disordered states. If true, then we might be living in the universe's epilogue rather than its middle chapters. Perhaps cosmos is already dead, in some fundamental sense, and what we experience as existence is just the long, intricate process of possibility resolving into finality, the last echoes of the cosmic story playing out in seeming slow motion. From our perspective within it, visualize the cosmos not as a sphere expanding outward, but as a tapestry unraveling, complex patterns emerging briefly before dissolving back into formlessness. Stars birth and die in spectacular fusion-powered displays. Galaxies collide in slow-motion cataclysms spanning billions of years, their spiral arms unwinding like cosmic clockworks running down. Black holes devour matter, and eventually each other, growing ever larger, waiting out the eons until only they remain. And then they too evaporate in whispers of hawking radiation, leaving nothing but empty space and the faintest ripples of spent energy. In this vision, consciousness isn't the universe's culmination, but its swan song, the most complex pattern possible before final dissolution. We are not the pinnacle of cosmic evolution, but its last gasp, the universe's attempt to know itself before it no longer can. Or perhaps something even stranger is true. What if our universe is actually a black hole in a larger cosmos? The mathematics of black hole interiors bears striking similarities to our expanding universe. Both involve space-time stretching in ways that defy our intuitions. Some theorists suggest that every black hole might contain an entire universe within it, with physical laws determined by the properties of the parent black hole. If true, then beyond our universe lies another, vaster cosmos, and we are inside one of its black holes, mistaking its interior for all of reality. This nested structure could continue indefinitely. Universes within black holes within universes. Within black holes, an infinite regression of cosmic matryoshka dolls. In this scenario, the edge of our universe would be the event horizon of the black hole containing us, a boundary we could never reach from within, yet which would appear completely ordinary to observers in the parent universe. These possibilities stretch our understanding to its breaking point and beyond. They remind us that our comprehension of reality is limited not just by our instruments or our mathematics, but by the very structure of our minds, evolutionary products designed to navigate the mesoscale world of predators and prey, not the foundations of reality itself. And yet, here we are, contemplating the uncontemplatable, imagining the unimaginary, reaching beyond our cognitive limitations toward truths that may forever exceed our grasp. This reaching itself is perhaps the most remarkable feature of cosmic evolution. Matter organized in such a way that it questions its own nature, origin, and destiny. As our journey nears its end, we're left not with final answers, but with deeper questions. Not with certainty, but with wonder. Not with completion, but with openness to mystery. If the multiverse theory is correct, then somewhere out there exists every possible version of you. Some almost identical, others radically different. Some who turned left where you turned right, some who said yes where you said no, some who never watched this at all. And in some versions of the cosmos, another you is watching these exact words right now, thinking exactly the same thoughts you're thinking, creating exactly the same relationship with exactly the same perceived universe. Or perhaps you are utterly unique. The only you that exists or will ever exist in all of reality. Perhaps consciousness is so improbable, so precious, that even in an infinite multiverse, your particular manifestation of awareness occurs exactly once. Here, now, in this moment, witnessing these words. Either possibility is equally astonishing. Either possibility means that this moment, your conscious experience right now, matters in ways beyond calculation. Either possibility means that your relationship with the cosmos, the universe that exists precisely because you exist to observe, it is the rarest of gifts, to be cherished during the infinitesimal cosmic moment of your existence. What lies beyond the edge of the universe? Perhaps it's not a what at all. Perhaps it's a who. We began our journey with a fundamental misconception, that the Big Bang was an explosion in pre-existing space, rather than the birth of space itself. We've traveled through quantum realms where certainty dissolves into probabilities, confronted the limits of our cosmic horizon, and contemplated realities that might exist beyond our observable bubble. We've questioned the nature of time, space, and even existence itself. And we've considered the possibility that consciousness isn't merely a byproduct of cosmic evolution, but an integral part of reality's unfolding. Yet for all our explorations, we've only scratched the surface of cosmic mystery. Every answer we've found has opened the door to deeper questions. Every boundary we've pushed against has revealed new frontiers beyond. This is the nature of true cosmic exploration. Not a journey with a final destination, but an endless recursion of discovery, where each revelation births new mysteries. Consider how far human understanding has come in just the last century. In the 1920s, we still debated whether the Milky Way was the entire universe. Today, we map the cosmic microwave background, detect gravitational waves from colliding black holes, and contemplate multiverses suggested by our most advanced theories. What might we discover in the next 100 years? The next 1,000? What cosmic truths remain hidden? waiting for minds capable of comprehending them? Perhaps the most profound realization is that the cosmos is not separate from us, but continuous with us. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in stellar furnaces billions of years ago. The carbon that forms the backbone of your DNA was synthesized in the heart of dying stars. You are, in the most literal sense, made of star stuff. When you look up at the night sky, you're not just observing the universe. You're part of it looking back at itself. This continuity between observer and observed suggests something remarkable about cosmic boundaries. When we ask what lies beyond the edge of the universe, we're not just asking about distant realms of space-time. We're asking about the limits of our own understanding, the edge between the known and the unknowable, between the comprehensible and the incomprehensible. And this boundary isn't fixed, but dynamic, expanding with each new discovery, each new insight, each new way of perceiving reality. What would our ancestors, huddled around fires beneath star-filled skies, have made of black holes or quantum entanglement or cosmic inflation? These concepts would have been not just unknown to them, but unknowable, beyond the cognitive frameworks available to their minds. Similarly, realities that are currently beyond our comprehension may become accessible to future generations as their cognitive tools evolve beyond our own. This suggests a chilling possibility. What if the universe as we understand it, with its quantum fields and curved space-time and four fundamental forces, is just the shadow of a deeper reality our minds are currently incapable of grasping? What if the true nature of existence is as far beyond our current understanding as quantum mechanics would have been to a Neolithic farmer? Each generation of physicists has believed they were approaching a theory of everything, only to discover new layers of reality beneath what they thought was bedrock. Newton's mechanics gave way to Einstein's relativity, which in turn revealed the quantum realm, which now points toward strings, brains, and higher dimensions. What further layers remain hidden? What fundamental misconceptions might we still harbor about the nature of reality itself? And here's a thought that should keep you awake at night. What if the universe is conscious? Not metaphorically, but literally. What if consciousness isn't an emergent property of certain complex systems within the cosmos, but a fundamental aspect of reality itself? What if awareness isn't something that arose within the universe, but something integral to its existence? What if, in some sense we can barely articulate, the cosmos is aware of itself through us and countless other observers throughout its vast expanse? This perspective, known as panpsychism in philosophy, has gained renewed attention from some serious physicists and philosophers of mind. It suggests that consciousness might be a fundamental feature of reality, like charge or spin, present in some form at all levels of existence. If true, then the boundary between mind and matter, between the observer and the observed, might be another illusion, another edge that dissolves upon closer inspection. Consider how this transforms our cosmic narrative. We typically think of consciousness as something that emerged late in cosmic history, a recent development on a single planet orbiting an ordinary star. But what if consciousness, in some form, has been present from the beginning? What if the universe has always been aware, and the emergence of life and intelligence represents not the birth of consciousness, but its complexification, the universe becoming more fully aware of itself? This isn't mysticism, but a serious philosophical position with potential scientific implications. It offers a different way of understanding our place in the cosmos, not as accidental observers of an indifferent universe, but as expressions of a reality in which awareness is fundamental rather than incidental. What does this mean for you, watching right now? It suggests that your consciousness, Your subjective experience of being might be connected to something vaster than you've imagined. Not in some supernatural sense, but in the most natural sense possible, as a manifestation of what the universe has been doing all along. The boundary between you and the cosmos, like all the other boundaries we've explored, might be more permeable than it appears. The edge between self and universe, between internal and external, between here and there, these too might be constructs of perception rather than fundamental divisions in reality. This doesn't mean you are the entire universe. That would be solipsism. Rather, it suggests you are an integral part of a reality that extends far beyond your individual awareness, yet includes that awareness as an essential aspect of its nature. You are how the universe experiences this particular perspective, this specific vantage point, this unique configuration of space-time. As our journey comes to a close, I invite you not to treat what you've learned as mere information to be filed away, but as a seed of wonder to be nurtured and grown. The questions we've explored aren't just academic puzzles, but invitations to a deeper relationship with reality itself, a relationship characterized not by certainty, but by curiosity, not by answers, but by ever more refined questions. What lies beyond the edge of the universe? What came before the beginning of time? What exists outside of existence itself? These questions may never find complete answers, but in asking them, we participate in the universe's own self-investigation. We become the means through which the cosmos contemplates its own nature, origin, and destiny. Share these questions with others. Discuss them over dinner, on long walks, under starlit skies. Let them inform how you see not just distant galaxies, but everyday reality, the wonders hidden in plain sight, the mysteries wrapped in the mundane. Let them remind you that familiar objects, a coffee cup, a houseplant, a loved one's face, are no less marvelous than supernovae or black holes when seen with eyes attuned to cosmic wonder. Let these questions inform how you live, how you treat other conscious beings, how you value your brief moment in cosmic history, how you contribute to humanity's ongoing dialogue with existence. Let them instill both humility at the vastness beyond our understanding and awe at our capacity to comprehend as much as we do. And above all, keep asking questions, especially those that have no easy answers. Keep pushing against the boundaries of the known, not just as a scientific endeavor, but as a fully human one. For in questioning the nature of reality, we fulfill one of our deepest purposes, to be the part of the universe that wonders about itself. The cosmos stretches before us, vast, mysterious, and largely unknown. Our observable bubble is surrounded by horizons both physical and conceptual. Beyond those horizons lie realms we may never directly observe, yet can explore through mathematics, imagination, and reasoned speculation. This exploration has just begun. So I leave you with one final question, perhaps the most profound of all. If the universe is the answer, what is the question? If all of reality, in all its staggering complexity and breathtaking beauty, is a response to something, a solution to some cosmic equation, an answer to some fundamental query, what could that question possibly be? Perhaps it's a question the universe is asking itself through us. The edge of the universe isn't somewhere out there in distant space. It's here, now, in the boundary between what we know and what we have yet to discover. It's in the horizon between our current understanding and our future insights. It's in the threshold between the questions we can articulate and those we haven't yet learned to ask. The universe has no final edge because discovery has no end. The cosmos may be finite or infinite. We don't yet know. But our journey to understand it, that journey is boundless. The universe may or may not have an edge, but our exploration of it never will.